Hey everyone, in this video we're going to go through question 7 from the 2023 Kilbaha VCE Methods Trial Exam, number 1, so no calculator, no notes, but you can have your formula sheet, or you will have a formula sheet. Alright, let's make a start. So the concentration of a drug in a body is given by F of t, where t is the time in hours, so I might just highlight that just in case it comes up later. After the drug is taken, initially the concentration of the drug is 0. So whenever you see initially, just remember that is when t equals 0. So when t equals 0, oops, got the equal sign, when t is equal to 0, so f of 0 is equal to 0. The rate of change of concentration of the drug is given by, okay, so it's given us the derivative. Using the product rule, show that the derivative of ft times e to the power of 0.4t is equal to that. All right, so what I've written there I don't think we're going to need it. I just wrote it down in because it was information from the question. All right, so we're basically finding the derivative of f of t times e to the power of 0.4t. So when we're using the product rule, we're going to let u equal f of t. So du dt is equal to the derivative of that, which we don't know what it is. So we can just write f dash t. But you can see in the question it has told us what it is. So I'm going to write that down. 50e to the negative 0.5 t minus 0.4 f of t. All right, and then v is equal to e to the power of 0.4 t. So using the derivative of e, we're going to end up with 0.4 e to the 0.4 t, which is on your formula sheet. So your derivative, so d dt is equal to, so using your product rule, we've got u times dv dt, so ft, oops, oh no, don't worry about that, sorry, ft times dv dt plus v times du dt. So we did write that down. I'm not going to fit it all in. Times, and I'll just put it underneath, 50e to negative 0.5 t minus 0.4. I'm running out of room. ft. All right, so what we want to end up with is this. So I know that we're going to have to be doing some cancelling somewhere along the line. And I also should put this in brackets because it's multiplying the whole thing. All right, so multiplying, now it's a bit hard to see. Let me just highlight this in something that can still see. So multiplying, oh, it's really hard to see, sorry guys. All right, so multiplying this by both these terms will mean that this is going to cancel out with this and this. So that is why we're left with 50e to the negative 0.5 t times e to the 0.4t. And when you've got the same base, so our base is e, and we're multiplying, we add our powers. So we've got 50e, then negative 0.5 plus 0.4 is negative 0.1. Now, this business over here could have expanded it to see that it did cancel out, but I've just cancelled it out there as well. So you can see it is equal to 50e to the power of negative 0.1 t. All right, in part B, we've got to show that f of t equals 500 times that. So let's just go back to part A. So we've got d dt of f t e. I don't want to get that confused with a negative. What is that? 0.4 t is equal to 50 e to the negative 0.1 t. All right, so to get rid of this derivative, we can just take the antiderivative of both sides. Hopefully not going to run out of space. All right, so the derivative of that is, I can take 50 out the front, we'll leave it there, divided by negative 0.1. And then we've got e to the negative 0.1t. So that is just on your formula sheet. So that gives us negative 5. Oh, what am I putting that dt on there for? Should be plus c because it's just a antiderivative. So 50 divided by negative 0.1 is negative 500. E to the negative 0.1 t plus c. And then we get f of t e to the 0.4 t. Now, we've got to work out the value of c. All right, and this is where this part comes in handy. So f of 0 equals 0. All right, so if f of t is 0, so that means your left-hand side is going to be 0, and then negative 500 e to the 0 plus c. So c is, so e to the power of 0, anything to the power of 0 is 1, so that makes c equals 500, and we're definitely going to run out of room here. So we've got ft, I'm just going to substitute that 500 in, e to the 0.4 t equals negative 500, e to the negative 0.1 t plus 500. And because we want to solve, we'll show that f of t is equal to that, I'm going to divide both sides by e to the 0.4 t. Dividing by e to the power of 0.4 t is the same as multiplying by e to the negative 0.4 t, so just the reciprocal. And what have we got there? Negative 500 e to the negative 0.1 t plus 500. All right, so in the question you can see 500 is taken out as a common factor. This is really annoying to squish everything in. And then we're just left with e to the negative 0.4 t minus e to the negative 0.1 t. All right, which is what we had to show. All right, a bit squishy there. The hard part was, I guess, leaving this on the left-hand side because we have to solve for f of t. You could have brought the e to the 0.4 t over to the right-hand side, but it does get a bit complicated with the c. So just solving for c first and then bringing that e to the power of 0.4 t over. All right, in part C, the concentration of the drug increases to a maximum. Find the value of t when this maximum occurs. Give your answer in the form blah, blah, blah. All right, so your maximum is when your derivative is equal to 0. All right, so if we go back to the start of the question. All right, so I'm going to have to make this smaller just so I can see it. So we've already got our derivative up here, so this is what I'm going to be copying down, but this f of t we just worked out in the previous question. So even if you couldn't do A or B, you could still do part C. So I'm going to have to keep scrolling back and forth to write this down. Sorry guys. 50 e to the negative 0.5t. Minus 0.4. All right, and then instead of writing f of t, I can just write what f of t is here, which is 500 times e to the negative 0.4 t minus e to the negative 0.5 t. And basically, that's going to equal 0. So we've got to solve for t when that is equal to 0. Oh God, what a pain. All right. All right, I'm actually going to pause it and then talk about it because I'm thinking, and it's very late. So I'll pause and then come back. All right, oh my gosh, what a tricky question. Okay, so I think I just rewrote it again. Well, I did rewrite it again. I can't remember how much I got through before I paused it. So I'm just going to leave it there. So if you want to write it down, do it now because I'm going to scribble all over this in a sec. All right, so expanding this negative 0.4 times 500 gives you 200. So that's where these 200s come from. And then we've got e to the negative half t and e to the 2/5 t or 0.4t. So same thing. You'll see I've changed it to fractions just because sometimes I prefer fractions. Okay, so we end up then with so the same pronumeral part, so e to the negative half t and e to the negative half t. So we can add the 50 and 200 to get 250 e to the negative half t. And then I've taken out the 50 as a common factor. So that just means I can then get rid of the 50 and we're just dealing with what I've got here in the bracket. So if I took one of those terms over to the other side, it just allows me then to eventually get the t's on one side, and then I'm on the right hand side I'm left with 5/4. All right, so using your index laws, because we've got the same base, we're going to do negative 2/5 minus negative 1/2, so that gives you t to the power of 10. Not much space here to do it, but you can do your fraction work sometimes just to the side. Then taking log base e of both sides, I'm left with t over 10 is equal to log base e of 5/4, and then multiplying both sides by 10 gives me 10 log base e 5/4, and just double checking, yep, it is in that format. And they all have to be positive integers, so if you perhaps did this part and ended up with some negatives, you've got to deal with those negatives because A, B, and C all have to be positive. All right, tricky question. Thanks, bye.